Okay, in this problem here, we have the normal to this particular curve, where A and B are constants, is equal to this situation here at the point x equal to 4. We're asked to find the values A and B. First thing I notice, there's two variables, so therefore I'm going to need two equations. Okay, the first equation I can do is I am going to find, at this particular situation, I can find the slope of this line, y is equal to negative 4x plus 22. And so the slope of the normal is equal to negative 4. And so the normal to the curve is equal to this. So the tangent slope is going to be equal to positive 1/4. So if I take the derivative of this value, y prime is equal to, let me rewrite this, ax to the 1/2 plus bx to the minus 1/2. So taking the derivative, I get 1/2 ax to the minus 1/2 minus 1/2 bx to the minus 3/2. So I know that this derivative is equal to 1/4 when x is equal to 4. So when it's equal to 4, the derivative is 1/4 positive. So if I plug this in, I get 1/2 ax 4 to the negative 1/2 minus 1/2 bx to the minus, not x, but rather I can make that 4. 4 to the negative 3/2 is equal to 1/4. Simplifying this, square root of that is 2, so it's, I flip it, so I get times a half, so this is 1/2 times a half is 1/4 ax minus, if I take the square root of 4 is 2, to the power 3 is 8, and negative that, so it's 1/2 b times 1/8 is equal to 1/4. And if I simplify that a little bit, I'm going to have 1/4 ax minus 1/16 b, and I don't know why I have an x in here. There's no x. X is 4. Let me try that. So minus 1/16b is equal to 1/4. I'm going to multiply by 16, so I get 4a minus, no I don't, yes I do, 4a minus b is equal to 4, and that I get that by multiplying everything by 16. So here is one equation with a and b. I need a second equation, and I have to use this somehow. I want to use x equal to 4, I have to find a point on the curve. And I know the normal of the curve where a has this equation at x equals 4. So if I think graphically what's going on, I have some crazy curve, and then here is my tangent line, here is my normal. At this point, my normal is negative 1/4, and that's when x is equal to positive 4. Okay, so x is equal to 4, and here's my axis. And so it goes here, the tangent is positive 1/4, that's here, at x equal to 4. Well, if I could find the y value here, and then I could have a point on the blue curve. Well, at x equal to 4, this point is on the normal line, it's on the tangent line, and it is on the blue function that we're looking for. So if I come along here and plug in 4 for x plus y is 22, I can see that y is equal to 22 minus 16 is 6. And so this coordinate here is 4, 6. This coordinate is on this function here. And so if I plug in that value, now, if I plug in, so here's my function y is equal to ax to the 1/2 plus bx to the minus 3/2. And if I plug in the point 4, 6, I get 6 is equal to a 4 to the 1/2. Oh, did I copy my function down wrong? This should be negative 1/2 plus b 4 to the negative 1/2. And I can then go 6 is equal to 2a plus, well, square root of 4 is a 2. Flip it over, I get 1/2 b. Multiply everything by 2, and so 12 is equal to 4a plus b. And so I'm multiplying everything by 2. So here is my second equation. I have two equations, two unknowns. I can solve them. If I had my calculator handy, I would simply put it into Polysmalt, but since I don't have it up and handy, I'm going to just rewrite this. A minus b is equal to 4. I'm going to add these two equations up. Those cancel and I get 8a is equal to 16, and so a is 2. Take that, plug it in. 12 is equal to 4a plus b. I know 12 is equal to 4 times 2 plus b. 8 minus 12 is 4 is b. And so a is 2 and b is 4. So recapping, at 4, my normal is negative 4 sloped here, and so my tangent is positive 1/4. So the derivative at x equal to 4 is equal to 1/4. That's one equation I can get using x equal to 4 and 1/4 as my slope. The second equation, I find the point when x equals 4, which is here, and that will enable me to find the equation or the coordinate on the curve itself, which will then help me find the second equation to find a and b.